On this video, another method of solving quadratic equations will be discussed. Solves quadratic equations by completing the square. For our first activity, perfect square trinomial to square of binomial. So we already have encountered these perfect square trinomials that can be written into the square of binomial in the last video. In writing these numbers in these expressions into square of binomial, we just have to consider the first term, which is a perfect square number, get the square root of that, get the sign of the middle term, and the square root of the third term, quantity square. So since this one is a perfect square trinomial, so therefore that can be factored into a square of binomial. The second one is also a perfect square trinomial. How do we know? We get the square root of the first term, therefore we have r, and then sign of the middle term, minus, and then the square root of the third term, which is 49, therefore that is 7, quantity squared. Now if we multiply r times negative 7, therefore we will be having negative 7r, and then multiply that again by 2. Therefore we get the middle term, which is negative 14r. And finally we have this one. We get the square root of s squared, therefore we have s, sign of the middle term, plus, and then the square root of the third term. Square root of 9 is 3, and square root of 64 is 8. How do we know if this factor is correct? So we just have to multiply s times 3 8, therefore we have 3 eighths of s, and then multiply that again by 2. Now in multiplying this, we can have 2 and 8 cancelled, therefore we have 4 and 1, resulting into 3/4 of s, which is actually the second term of this trinomial. Make it perfect. On this activity, we are going to give the terms on each item, on each expression, to make the following a perfect square trinomial. So from the previous activity, how do we know that the given expressions are perfect square trinomial? Of course, the first terms, x squared, f squared, and s squared, are perfect square. At the same time, the third terms here should also be perfect square numbers. And if we get the square root of the first term and then the square root of the second on the third term, and then multiply that by 2, therefore that should be the middle term. And so if we are going to reverse that process, first we multiply that by 2, therefore we divide that by 2. If we get the coefficient of this one, we have 2, and then reversing the process, we have to divide that by 2, therefore we have 1, and then we get the square root of this term, this time we square them, so therefore this is 1. From the previous activity, we just have to reverse the process. Again, we get the square root and then multiply that by x, the square root of the first term, and then times 2. This time we divide by 2 and then we square that number. Again, let's have negative 30 divided by 2 and then squaring that number. Therefore we have, correct, 225. And number 3, how about this one? Can you answer the third one? Okay, correct. So again, we just have to get negative 2/3, and this time divide that by 2, or we can also write this one as negative 2/3. Instead of dividing by 2, why not multiply that by 1/2? And then quantity square. Again, if we are going to divide something by 2, we can also do that by multiplying it by 1/2. So we can have this one be cancelled. Therefore, the answer is 1/3 only. Square that, we have 1/9 to make this perfect square trinomial. Next activity, finish the contract. The shaded region of the diagram below on the next slide shows the portion of a square-shaped car park that is already cemented. The area of the cemented park is 600 square meters. Use the diagram to answer the questions that follow. So we have already illustrated here. This is the square car park, and then portion of which is already cemented, and the other one or the other part is not yet cemented. So for question number 1, how would you represent the length of the side of the car park? How about the width of the cemented portion? So if we are going to have the dimensions here, since this one is a square, therefore from this portion up to this portion, that is S, and therefore that is a square, therefore this one is also S. Whatever that dimension or whatever that length is. How about the width of the cemented portion? So this is just the cemented portion. How are we going to represent that one? If the whole side is equal to S and this one is 10 meters, therefore we can have S minus 10 as the width of the cemented portion. Question number 2. What equation would represent the area of the cemented part of the car park? This is the cemented portion of the car park, and we are looking for the equation that would represent this area. This is now a rectangle, therefore we have A, or the area, is equal to length times width. But our length this time is S, and our width is S minus 10. And then question number 3. Using the equation formulated, how are you going to find the length of the side of the car park? Remember that we already have here the area of the cemented park is 600 square meters. So therefore we can substitute that here. 600 is equal to S times S minus 10. And then simplifying further, we can have S squared minus 10S is equal to 600. And then having that here, we have S squared minus 10S is equal to 600. And based on the skills that we have earlier, how do we make this expression perfect square trinomial? So let us have the procedure that we have earlier. That is -10, we get the coefficient, divide that by 2, and then we square that, giving us 25, correct? And then adding that to both sides of the equation. So we have S squared minus 10S plus 25. Whatever you add on the left hand side of the equation, you also have to do that on the right hand side of the equation. 600 plus 25. So giving us S, and this is now, the expression on the left hand side of the equation is now a perfect square trinomial. Therefore, we get the square root of S squared, which is S, the sign of the middle term, and the square root of the third term, which is 5, quantity square. So remember that perfect square trinomials can be written as square of binomial is equal to 625. And let me have the continuation of solution here. Our next step here is to use the first method that we have discussed, which is the square root method. We get the square root of this and then square root of 625. Let's have the solution here. The square root of S minus 5 quantity square will be S minus 5 only is equal to, and then the square root of 625 will give us the positive negative 25 since variable here is involved. Therefore, we get the positive negative square root of that number. And then we will be having s minus 5 is equal to first positive 25. Therefore, we have s is equal to, add 5 to both sides of the equation. We have 30 as the first solution. Or we can also have s minus 5 is equal to, after the positive 1, we have the negative 25. And then add 5 to both sides of the equation. We have s is equal to negative 25 plus 5 is negative 20. Now, since we are talking about the dimensions of the side of the square, this cannot be negative. Therefore, this one is extraneous. Therefore, we accept the side of the square, or the side of the car part, is equivalent to 30. Now, learn to solve quadratic equations. What are the steps that we have done on the previous activity? So again, we have ax squared plus bx plus c is equal to 0. Our illustrative example here is 2x squared plus 20x minus 150 is equal to 0. Now, if a is not equal to 1, therefore there is another step here that we have to divide both sides, by a. In our example here, we have to divide everything, since a is not equal to 1, divide everything by 2. And 0 divided by 2 is just 0. Therefore, we have x squared plus 10x minus 75 is equal to 0. Notice that this one is not a perfect square trinomial because negative 75 do not have square root. Now, isolate the terms with variable on the left hand side. Therefore, we have x squared plus 10x is equal to 75. Isolated now the terms with variables on the left hand side of the equation. Add the square of 1/2 of the coefficient of x on both sides of the equation. So that is the procedure that we have discovered on the last activity. We have to divide 10 by 2. We have here 10 divided by 2 giving us 5, and we have to square that. So therefore, we are going to add 25 to both sides of the equation. And we have noticed here that the left hand side of the equation, x squared plus 10x plus 25, is now a perfect square trinomial, which can be written as square of binomial. So what do you think is the factor of this perfect square trinomial? Correct, that should be x plus 5 quantity square is equal to, simplify this, we'll be having 100, and we now have to solve by extracting the square root. So get the square root of both sides of the equation, giving us x plus 5 is equal to positive negative 10. And for our solution, we have positive 5 transpose, we have 10 minus 5 is equal to 5, or negative 10 minus 5, we have x is equal to negative 15. Okay, so let us put that into examples, completing the square. So again, what is the first step? If a is not equal to 1, correct, we divide everything by that coefficient, which is 2. If in case this is 5, therefore we divide everything by 5. If that is negative 3, therefore we divide everything by negative 3. Dividing everything by 2, giving us x squared plus 4x minus 5 is equal to 0. And for our next step, again, isolate the terms with variable on left hand side of the equation. We have x squared plus 4x plus blank, the term to be added, is equal to negative 5 transpose to the other side will become 5 plus blank. Okay, get the coefficient of the middle term. We have 4 divided by 2 quantity square. So that gives us 4. And this is now a perfect square trinomial to be written as the square of binomial. What is that square of binomial? Correct, x plus 2. Quantity square is equal to 9. And then we just have to take the square root both sides of the equation. Therefore, we have x plus 2 is equal to positive negative 3. And then for continuation, we'll have x plus 2 is equal to 3. Therefore, we have x is equal to 1. Or x plus 2 is equal to negative 3. Therefore, we have x is equal to negative 5 as our solutions. Next, we have x squared plus 3x minus 18. X squared plus 3x minus 18 is equal to 0. Isolate the terms. We have x squared plus 3x is equal to 18, and then plus blank. Let us prepare this one. Next step. What should be added to both sides of the equation? Correct. Let us show that one. 3 divided by 2, the coefficient of the middle term, then quantity square. Therefore, we have 9 over 4 to be added on both sides of the equation to make the left-hand side a perfect square trinomial. So get the square root. Let's have x, sign of the middle term, and then the square root of the third term, which is 3 over 2. Quantity square is equal to, how about this one? 18 plus 9 over 4. Okay, so making them similar fractions, we have 4, and then 18 times 4 gives us 72 plus 9 over 4. So we can now add them. So let's have the solution here. We have to take now the square root of both sides of the equation, assuming we have already added this one into 81. So therefore, we have x plus 3 halves is equal to the positive negative. This will become 81. The square root of that is 9. And the square root of 4 is 2. So we have the first solution. X is equal to 9 halves minus 3 halves. Therefore, we have x is equal to 9 minus 3 gives us 6 divided by 2, which is 3. Another solution here, we have x is equal to, after the positive 9 halves, let's have the negative 9 halves, and then subtracted by 3 halves. So they are both negative, we just have to add them. Negative 9 plus negative 3 gives us negative 12 divided by 2 is negative 6 as our solution. And finally, we have x squared minus 6x minus 41 is equal to 0. So isolating the terms with variables on the left hand side of the equation, we have x squared minus 6x plus blank is equal to 41 plus blank. So what is that term to make this a perfect square trinomial? Correct. So negative 6 divided by 2 quantity square will give us 9. And then writing this into square binomial. Correct. So therefore we have x minus 3 quantity square is equal to 41 plus 9 gives us 50. Getting the square root both sides of the equation, or the square root method, we have x minus 3 is equal to positive negative. How about square root of 50 this time? This is not a perfect square number. But remember that 50 can be written as 25 times 2, and one of which is a perfect square number, which is 25. Therefore, we can get the square root of 25, which is 5. But for the square root of 2, that will remain as square root of 2 if we do not have calculator in our side. So we can have this one. And simplifying further, let's have our space here. we have x minus 3 is equal to the positive 1 first, 5 square root of 2. So we have 3 plus 5 square root of 2 as our first solution. Another solution, we have x minus 3 is equal to, this time, the negative 5 square root of 2. So we have x is equal to 3 minus 5 square root of 2. So these are the solutions, or we can also have x is equal to 3 plus minus 5 square root of 2. So complete me. For this activity, you are going to do the same procedure that we have done on our examples, but we are going to discuss your answer in our synchronous session. So we have 3 numbers for you to practice, and a problem for you to answer applying the idea of completing the square. Represent, then solve. So this will be question number 1, and for question number 2. Okay, that's it for this video lesson. The resources used here are the following. Thank you.